rest of today, I want you to look at all possibilities for all situations when we do these scenarios. Okay, so we will have 4 different lens and mirror combinations, right? 2 converging and 2 diverging. And then we'll put the objects at different places. We'll put them on the real space and we'll put them on the imaginary space. And then we'll bring everything together. We are going to draw 16 different configurations. Take a deep breath. We can do this. But once you're done with this activity, then you will 90% of the time never go wrong. I mean, we can still go wrong. I still go wrong. But because we've seen them once, we won't go wrong in the future. Are we ready? Okay, here we go, guys. So the first one, let's look at lenses. So we are going to use these combinations. So my object is going to be at 15 centimeters. My object is going to be at 5 centimeters. My object is going to be at -5 centimeters. And my object is going to be at -15 centimeters. And I'm going to, for the sake of simplicity, only use focal lengths that are 10 centimeters, just so it matches with my boxes. For lenses, I'm going to have the 2 situations where I'm going to have a focal length of +10 and a focal length of -10 centimeters. So case 1 and case 2. This is going to be my converging situation, and this is going to be my diverging situation. Okay, can I draw? So let's do the converging case first. So I'm going to do converging. So what did my symbol look like for converging? And it's a lens, so should it be on both sides? And I'm going to use my 2 boxes as my focal points. So each box for me is 5 centimeters. So where should I put my object? At 15. Okay, so I want you to bring out your notes where I said what the parallel and the chief and the focal points do. Okay, so for my converging case, what will my parallel ray do? It will start at the object and it will go parallel to the optical axis. So this is where my parallel ray starts. And then I said it has to go through my focal point. And I tend to do this to remind myself that all of rays are coming from this side. Okay, now next, what's my next ray? Chief ray. And what does a chief ray do? It starts at the top, goes through the center, and it keeps going straight because it's a lens. And what's my last ray? And it's green in color. It's my focal ray. So it has to go through the focal point until it hits somewhere here. And then it has to go straight out. This is my P. And this is my F. And it's kind of important to note where these rays are going and coming to. And where will my image form? My image will form wherever these three meet. That's where my image is going to be formed. And this is now going to be called object, and this is going to be called image. So if I use my mirror equation, I can also confirm this by saying 1 over f equals 1 over object plus 1 over image. My focal length is 10. My object is plus 15 plus 1 over I. Solve for it, I can get I. 30?
Yeah.
And this 30 centimeters is how far this is going to be. Of course, we're not drawing it to scale, so we're going to probably be off. Now look at the diverging case. Diverging lens. So a diverging lens will look like, and I knew the diverging looks like this. And I don't fill it in, right? And that means I have to use both focal points, keeping the focal point the same. So this is my one focal point, this is my other focal point, and I'm going to use my same object at 15. I'm going to draw my little arrow that goes like this. My rays don't change. I will still have parallel, chief, and focal, same three rays. But now this is the diverging case. Remember, this was the converging case at the top. So my parallel ray converged in. So in this case, my parallel ray starts parallel, but now it has to go away. By how much it will go away depends on this focal point. Okay, what will the chief ray do? It will start at the top, go through the middle, and then keep going straight down. Because the chief ray, that's the only thing it does. Now this is a lens, right? So the focal should use which focal point? The one to the left or one to the right? It's already used up the one to the left. So it has to use the other one. But the rays actually don't go here. So with a dotted line, I'm showing the rays where they actually don't go. Okay? What happens to the focal after it hits the system? It has to change. Also, always remember that rays can only change when there is an interface in the middle. They cannot just randomly change. So your focal ray goes that way. Now, I don't see a spot where all three meet. Do you? So then what you do in that scenario is that you will extend the lines backwards and forward until you find a spot where all three meet. And voila, this is a spot where all three meet. And so your image will be here. And your object is here. Another thing I want to tell you is that your objects are currently in the real space. This image is in the real space. That is why there is a positive on the image. This is the real space for a lens. This is the imaginary real space for the object. This is the imaginary space for image. This is the real space for I. And imaginary space for O. That means if you solve this equation, you should get an image that's actually negative. And I believe I calculated it and I got a negative 6 centimeters. And remember, this negative 6 centimeter means that this distance here, everything is measured with respect to the lens or the mirror. Okay? So a negative image means it is a virtual image. When it's a virtual image, that means it cannot be projected onto a screen. Got it?